Today, we'll explore how the James Webb Space Telescope, or JWST, is deepening a crisis in cosmology by looking deeper into space. This video will give you an in-depth look at the expansion of the universe, dark energy, and the big unknowns in cosmological models. If you're ready, let's start exploring this fascinating topic. We know that the universe is expanding. As we talked about in the dark energy video, no matter which way we look in the universe, galaxy clusters are moving away from us. In fact, closer galaxy clusters are moving away from us more slowly, while more distant galaxy clusters are moving away from us faster. This can be explained by the fact that the Big Bang happened simultaneously across the entire fabric of space-time. Before the Big Bang, the universe was incredibly small on a quantum scale. It went through a period of cosmic inflation, expanding by at least 10 to the 78th power times its volume in a fraction of a quadrillion times a quadrillionth of a second. This inflation started the expansion of the universe as we know it today. The initial expansion slowed down, but never stopped. When cosmic inflation ended, our universe was at least the size of a grapefruit and continued to expand. For 9 billion years, the rate of expansion slowed down under the influence of gravity. About 50,000 years after the Big Bang, it began to take a few hundred million years for the universe to double in size. However, dark energy began to exert its influence and increased the expansion rate again. Today, the universe continues to expand at an accelerating rate, and it will take billions of years for the expansion rate to slow down. The expansion rate, called the Hubble constant in honor of Edwin Hubble, who first discovered the expansion rate of the universe, shows that the universe is expanding in all directions at every point. The Hubble constant is a time-varying variable. It is currently measured at 73 kilometers per second per megaparsec. While this constant helps us understand the rate at which the universe is expanding, it can be measured in two different ways. The first method is to measure the speed at which distant stars are moving away from us, and divide that speed by the distance between us and those stars. We can determine the speed of a star by measuring the amount of redshift in the spectrum of its light. However, measuring distance is more difficult. Using a method called the cosmic distance ladder, we first precisely determine the distances within the solar system, and then calculate the distances to more distant stars. With the parallax method, we determine the distance to nearby stars. This method uses telescopes to measure the view of stars from different angles, and uses geometry to calculate distances. For more distant stars and galaxies, we use stars called Cepheid variables. These stars make regular pulses, and their brightness changes regularly. Henrietta Leavitt discovered that the frequency of these pulses is related to the actual brightness of the stars. We use Cepheid variable stars as standard candles that allow us to precisely measure huge distances across the universe. However, to measure more distant galaxies, we may need to use brighter objects like supernovae. Type 1a supernovae help us measure distances accurately because they always explode with the same brightness. Independent research teams have calculated the Hubble constant using different standard candles and data sets. These measurements show an expansion rate of 73 kilometers per second per megaparsec. However, the precision of these measurements is still debated. The second method is to use data from the cosmic microwave background radiation, or CMB, to calculate the expansion rate of the universe. The CMB is a radiation field of photons emitted about 380,000 years after the Big Bang. This radiation shows the temperature and density distribution of the universe at that time. Using CMB data, we can calculate the expansion rate of the universe through simulations. The Hubble constant obtained with this method was measured to be about 67.7 kilometers per second per megaparsec. The difference between these two measurement methods points to a crisis in cosmology and is called the Hubble tension. The James Webb Space Telescope was used to more precisely verify Hubble's measurements. With its larger mirror and more sensitive sensors, Webb confirmed the Hubble data almost exactly. However, This verification did not solve the cosmological crisis. On the contrary, it deepened it. Some researchers have made an independent measurement of the Hubble constant using red giant stars. This method provided data that fell between previous measurements, but was not enough to fully resolve the cosmology crisis. Perhaps there are other factors we don't yet know about that help us understand events in the universe. Gravity and dark energy play an important role in the expansion of the universe. However, we do not fully understand the nature of these forces. More research is needed to learn more about the nature of dark energy. Modern cosmological models are quite successful in explaining the expansion of the universe. However, there is much more to be discovered beyond these models. Perhaps there are things we misunderstand about dark energy and dark matter. These unknowns will allow us to reach a deeper understanding of the expansion and dynamics of the universe. The future of the universe depends on the rate of expansion and the nature of dark energy. There are three possible scenarios. The universe continues to expand at an accelerating rate and experiences a massive rupture. Dark energy keeps the universe at a constant size, or dark energy weakens and the universe collapses in on itself. Observations from the James Webb Space Telescope continue to reveal major crises and unknowns in cosmology. Scientists continue to work to learn more about the expansion of the universe, dark energy, and gravity. Perhaps these studies will help us unlock the secrets of the universe and radically expand our understanding of cosmology. See you in the next video. Bye.